I'm surrounded by a bunch of innovative thinkers, very creative. There is that entrepreneurial spirit. The whole world of uncrewed systems and emerging technologies is just expanding so fast that whenever I show up to work, I'm always hearing about a new technology or a new capability and a new possible use case or a new problem that we can solve using UAS.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 339. How is NOAA using drones? For that question, we head to Lakeland, Florida, and speak with Commander Paul Hemmick, Chief of NOAA's UAS Division at the Aircraft Operations Center. Commander Hemmick received his NOAA Commission in 2004, serving in multiple operational and staff-level assignments throughout his 16-year career. He's piloted large ships, flown planes, and is now heading NOAA's UAS operations. In this role, he oversees safety, policy, and fleet oversight spanning a wide range of UAS missions. With the recent formation of NOAA's UAS Operations Center, he is involved with implementing emerging UAS technologies to force multiply data collection and scientific operations across the agency. In this edition of the Drone Radio Show, Paul talks about NOAA's mission, the use of uncrewed systems to study hurricanes, and the role of NOAA's UAS division in spearheading value-added research using drones. But before we hear from Paul, I want to thank those of you who are supporting my funding campaign. Whether it's $1, $100, or much more, you can help defray the cost of production and keep the podcast going and growing. Go to droneradioshow.com/donate. And by the way, if you have a great story on the use of drones that you'd like to share in a podcast, contact me at randy@droneradioshow.com. So let's learn how NOAA is using drones with Commander Paul Hemmick. Let's pick up the interview where I asked Paul to introduce himself.
I'm Commander Paul Hemmick. I'm the Chief of NOAA's Uncrewed Aircraft Systems Division.
Paul, I think most people have heard of NOAA, but can you tell us what does NOAA stand for and what does it do?
Yeah, NOAA stands for National Oceanic and Atmospheric Administration. We're a federal agency, a science agency that falls under the Department of Commerce. And within NOAA, we have a number of different line offices, 6 line offices, in fact. So we have the National Marine Fisheries Service and the Office of Atmospheric Research, the National Ocean Service, NESDIS, which is a long acronym, but that's our satellite division, essentially, the National Weather Service, and the Office of Marine and Aviation Operations, which is the line office that we support directly.
What is the mission of NOAA?
So the primary mission of NOAA as an agency is to characterize our environment, to collect data and observations using all the science and resources and tools and personnel available to, again, advance our knowledge and understanding of our environment.
And how long have you been with NOAA?
I've been with NOAA for almost 18 years now. So I'm a NOAA Corps officer, by the way, and I'm a commissioned officer, and been around NOAA, the agency, being on a NOAA ship and driving a NOAA ship to operating NOAA aircraft and staffing various positions in between, namely the Space Weather Prediction Center and also our OMAO headquarters up in Silver Spring, Maryland.
How did you become part of the organization?
I got my graduate degree in public health, actually, about 18 years ago now. I heard about NOAA, the NOAA Corps, actually, through a friend of mine who was in the Army that was trying to do an inter-service transfer into NOAA, into the NOAA Corps. And that's where I first heard about it, word of mouth. And so I have this appreciation for anything and everything that involves the ocean. So being a California kid, I was always in the water. And I was, science-minded, so I had this sort of drive to combine my love for, the oceans with my science background and through basic training, going to a ship for a couple of years and, playing a role in pretty important mission, in fact. So, fisheries stock assessments in the Gulf of Mexico, that was the chief activities that we were doing aboard the NOAA ship I was assigned to. So I never thought in a million years that I would be driving, 170-foot stern trawler of all things. So, but again, that led to more doors and opportunities within NOAA and the NOAA Corps, that being flight school and now serving as the chief of the Uncrewed Aircraft Systems Division, or UAS Division.
Yeah, let's talk about the Uncrewed Systems Program. Can you share with us the evolution of the program within NOAA?
NOAA's UAS efforts began roughly 8 or 9 years ago, started small. And by the way, our office is located at NOAA's Aircraft Operations Center. So that's the AOC, currently in Lakeland, Florida. So about 8 years ago, our program kicked off. And it was pretty much fledgling. We trying to get the program off the ground. You've got pretty immature regulations at the time, trying to just figure out what our space is. And so, now you fast forward to, 8 or 9 years later, and now what you're seeing in NOAA is a whole new program being developed. The Uncrewed Systems Operations Center is now its very own program within the Office of Marine and Aviation Operations. And so now what we're seeing is a consolidated effort by NOAA, by the agency, to manage NOAA's overall UAS efforts, right? And so there's a lot going on out across the agency and in the field and in all those different line offices that I mentioned there. Now we have a pretty sizable fleet, not too big, not too small. We have, we're only about 130 or so UAS out in the field, but and the same number of pilots. But again, these pilots that we're talking about, these remote pilots are the best and brightest, researchers and scientists in their field. So whatever they're studying, they are or researching or collecting data on, they are now using UAS to essentially force multiply what they're doing and what they're trying to achieve. So that's the exciting part. We've gone from the nascent, really immature program to now a really visible program within the federal space, and is exciting because Congress has eyes on the program, and other folks around the world are watching what NOAA is doing with uncrewed systems, both in the air and at sea as well.
With an organization as large as NOAA, how are the UAS decisions made? Are they centralized where your section develops the programs, or are the applications developed in the field at different offices?
That's a great question, and it's really the latter there. So we are not a centralized division or shop, if you will. Here at the UAS division, we're not telling what the scientists or what the researchers need to procure or operate or to use. So what's really happening in our model is, the researchers out in the field are defining the requirements for their particular area of expertise. They know the requirements better than anybody. They know what they need to use and what they need to fly and what sensor or payload combination they need to gather the data. And so what our role is here is to facilitate that entrepreneurial spirit, essentially, is to help guide the choice of a particular UAS and help maybe integrate that payload or a sensor into that UAS, figure out training solutions for that platform, make sure that the platform has an airworthiness or it's airworthy. And then at the end of the day, it's also about following policy and governance and all those sort of the dry stuff, right? The rules and the constraints that we all have to live by as Part 107 pilots, or we make sure that everybody's sort of following the rules and making sure that we're all safe and efficient pilots out there.
I understand that NOAA has an uncrewed systems strategic plan. Can you tell us about it and the interface with Congress?
The Uncrewed Systems Strategy Plan, that was an effort that was undertaken last year, so 2020. And 2020 was the year that Congress provided NOAA funding, right, to stand up the Uncrewed Systems Operations Center, so the UXS Operations Center. And part of that effort was to develop a 5-year strategy. So what is NOAA going to do with this funding? What are the goals? What are the missions? What are the opportunities? What are the challenges? What are the gaps, right? So My role personally was just to be part of that team, part of that brainstorming team, to come up with NOAA's overall strategy to capture, okay, what is the agency going to be able to accomplish with UAS, and what are some of the other long poles here? So data storage and big data and uncrewed systems utility, both in the air and at sea. Again, NOAA's work spreads out across all regimes here. So we're talking about a lot of different activities, ocean related. So the strategy is essentially trying to come up with a coordinated effort to consolidate all of the uncrewed systems, resources and knowledge and expertise, and just drive the agency forward. And so that's where we're at with the strategy plan.
What are some of the key priorities of the plan?
The top priorities or the top goals that came out of the uncrewed system strategy effort last year essentially boil down to 5 distinct goals. And so it's really about coordinating and supporting uncrewed systems operations at a broad enterprise level. It also included expanding uncrewed systems applications across the entire suite of NOAA's mission portfolio. There's also a very big push to accelerate the transition of research into applications or research into routine operations. We do a lot of research and development. A huge piece of the strategy is figuring out the way forward to convert research and development into an operational framework. And then another goal here, and this is important too, is the fact that NOAA is trying to strengthen and expand partnerships in the federal space, academia, and industry. So there's a big opportunity to leverage experience and just the amount of talent out there. So that's a huge piece to the strategy. And finally, it's really about promoting workforce proficiency in using these assets, right? So making sure that anybody in NOAA that's using an uncrewed system, again, whether it's in the air or at sea, is properly trained and proficient in doing it all safely. So that encapsulates the uncrewed system strategy that NOAA is putting forward.
Let's talk about the details. Can you give us a sense of how many UAS operations are occurring at NOAA?
So this year in FY21, NOAA's UAS division approved 67 unique operations, ranging all across the board in terms of size and scope and area of operation. And I'll get into that in just a second here. But, we had about 1,500 flights, a little over 1,800 minutes flown. So there you go. That kind of captures the range or the some of the metrics that we look at. But in terms of like the areas that we're flying these UAS, and primarily small UAS, I should let you know, Randy, that the types of UAS that we're using are primarily small UAS, the quadcopters, hexacopters, octocopters, a mix of vertical takeoff and landing and fixed wing hybrids. So we're not using a large UAS. I think in the future, you're going to see more adoption, more opportunities to leverage larger UAS. But right now, primarily small UAS, fixed wing, vertical takeoff and landing, VTOL, et cetera.
From NOAA's standpoint, what's the value that drones provide?
There's a lot of opportunity in gathering data on various populations of animals, right? So in very hard to reach places too. So that's where we're getting a lot of benefit here, where we're able to get UAS out into the field to help augment crewed aircraft surveys or ship or boat launch surveys. We're finding out that UAS utility is very effective in places like Alaska or like the Aleutian Chain, where weather is always an issue, or just getting out there and getting ground surveys and folks out to actually conduct the work. It's a gargantuan effort. And so UAS is providing a safe and effective solution to getting photogrammetry data on congressionally mandated and protected species, right? Assessments. An example of that is the northern fur seal population up in the Aleutians. So we have folks that are out there collecting photos and they're bringing all that imagery back to the lab and having to process it, which is really a great opportunity, is that the AI, artificial intelligence, and machine learning technologies are starting to fold into what they are doing. So that is also serving as a force multiplier.
You mentioned the Hurricane mission. Can you talk more about how UAS is enhancing that mission?
Yeah, the Hurricane mission is one of NOAA's core projects, right? And understanding and characterizing hurricanes, both from a research standpoint and from an operational standpoint, surveillance and that type of thing. So what we're doing now is figuring out ways to not only deploy drop-ons, which are tubes that are shot out of the P3 aircraft, right, at altitude, which collect, the various environmental parameters, temperature, humidity, wind direction, and those types of things. We're now looking at ways to utilize UAS in a similar configuration, right? So an example of that is we have the Altius, which is being tested. Again, these are in test mode right now, not operational, but the Altius is a great example of what science and innovation, trying to get a UAS to be launched out of a P3 and be able to collect data in the storm environment, be able to loiter for a number of hours, and again, essentially characterize the boundary layer or the lower levels of the hurricane or the storm, essentially just bolstering the efficacy of the data, right? So getting more data in the environments where we can't send our aircraft into. These are technologies that are aimed at better characterizing the storms and understanding how to resource manage, or how to provide data to our stakeholders like DHS or FEMA when it comes to evacuating personnel or people, right? We are now realizing that with these rapidly intensifying storms, we need more data. We need more observations. And so this is a prime example of NOAA trying to get ahead of this and be able to deploy UAS into the storm environment.
How do NOAA pilots fly a drone during a hurricane? Does the UAS fly above the storm, through the eye, or through the storm itself?
So the opportunity here again is, and the primary opportunity is to get the UAS down into the boundary level, or boundary layer is the lower level part of the storm where it's simply unsafe and too risky to put our aircraft into that environment. So the purpose here is to have a UAS that can loiter in that environment and provide the data to the aircraft while it is out flying its butterfly pattern. It might be 150 miles away from the UAS, but the idea here is that the P3 aircraft will be flying its predetermined pattern. The UAS, in this case, the Altius, and there's a couple other products that are also being tested here. They're going to be flying in the eye of that storm and trying to just give us a better picture of what's happening in there, giving us fixes and giving us the wind direction and wind speed close to the eye wall, right? So you think about sending something like this into the storm environment, you would imagine it would just break up into pieces immediately. But the goal here is, again, to keep it relatively safe and work with the winds, right? So we don't want to, unfortunately, the one thing here is that these are expendable. So once they are launched, we are not able to recover them, but we expect to see great gains from these types of UAS.
What does the Altius system look like?
The Altius 600 is a relatively small aircraft. Again, this is going to be shot out of the belly of the P3, almost like in a drop-on tube, if you will. And essentially what occurs is once the Altius is deployed, it essentially immediately spreads its wings. It's got a propeller behind the V-tail, fairly small, about 100 inches in wingspan, only about 7 feet in length.
Where are the drones controlled from?
The Altius is controlled, command control link from the P3 aircraft. So that's the idea. So while the P3 is flying its pattern, the area or the Altius can be controlled from a person in the aircraft.
Can you share what you've been able to glean from the mission so far?
We're so early, so I can't really talk too much about it, but I can speak to the boundary layer again. I mean, that's really the core issue, or the nut we're trying to crack here is getting data from the UAS, from the lower level of the hurricane, where we just have not been able to send our aircraft into. So that is the big opportunity for this type of UAS activity. And so what we're all seeing are rapidly intensifying storms. What I mean by that is, you can have a Category 3 or Category 2 hurricane, go to sleep, wake up the next morning, and it could be a Cat 4 or even a Cat 5. And I think, with the rise in sea surface temperatures, and the conditions are ripe for these rapidly intensifying storms. And we don't have a firm grip on that, right? So what we're good at right now is taking fixes and understanding where the storm is, right? We know where the storm is going. Coming up with that hurricane track is also the name of the game. And so So NOAA's done a good job of that, and that's what we use these aircraft for. We use our crewed aircraft, the P3s in the Storm and the G4 jet above, and with all sorts of other assets, satellites and buoys and that type of thing. We're able to narrow down the cone of where landfall may occur. We've been doing a pretty decent job, I got to admit, but the challenge here again is the rapid intensification of these storms. And it's a pretty scary thing, right? So anybody that lives down here in the Southeast or a hurricane affected region is paying close attention. So what better way to get the data we need than to send drones or UAS into the environment where we simply cannot put human beings in harm's way.
Reminds me of the movie Twister, where the tornado hunters had the prototype data balls that would model the storm.
It's very similar to that. It's getting up close and personal with the storm. I can mention real quick that we're not just doing this in the air, and I think it's pretty important, as I've mentioned, that when I talk about uncrewed systems in NOAA, we're not just talking about UAS. We're also talking about drones on the surface and below the surface. And so, example of that is a sail drone, which this past field season, NOAA operated a sail drone that went into the eye of Hurricane Sam. So that's another example of NOAA being able to get UAS or uncrewed systems, I should say, into these extremely savage environments.
NOAA is also developing something called Horus. What is that?
Horus stands for High Altitude Operational Return Unmanned System. That is the long drawn out title of that project. So this project in particular is being run out of NOAA's Global Monitoring Laboratory, and that's in Boulder, Colorado. So what this team is trying to accomplish with their UAS project is getting essentially a glider UAS all the way up to about 75,000 feet using a balloon. It's got a specialized payload in it called the Air Core. And the beautiful thing here is that the Air Core payload, once the glider is released from 75,000 feet, its goal is to capture a column of air, right? So similar to obtaining an ice core, a column of ice off the Greenland ice sheet, if you will. So you can get a lot of information, a lot of data, historical information too, from an ice core. Imagine what you can get from an Air Core sample from all the way up 75,000 feet down to the surface. And the idea there is to get this sampling equipment all the way up to the altitudes where we just simply can't get routine observations. NOAA sends up balloons, weather balloons, quite often. That's something that we're quite good at. That's a one and done type of thing. What we haven't been doing very well is recovering payloads. So this Horus project, aims to send up one of the strongest payloads that we have, right, in terms of air sampling for greenhouse gases. And I'm talking about CO2 and methane and carbon monoxide and a number of other gases and elements. So that payload is able to, which by the way, is on board this glider I'm talking about. It's a 6-foot wingspan, portable glider, fixed wing. This glider will make its way back down to Earth from 75,000 feet, deploy a parachute, and all the while collecting a column of air or a sample of air, an air core. And so you can imagine, I'm sure the audience is wondering, well, how does NOAA get away with doing something like that? And so, as I mentioned with the Altius project, this is a research and development project. This is not an operational project or a routine operational project right now. We are working with the FAA to try to figure out, all right, how do we characterize this? Is this a balloon operation, like a Part 101 operation? Is this a Part 91 operation? So to be honest with you, we're trying to work out the details on this one. But the science team is strong. The technology is strong. The UAS is proven. We had a test of it back in May out in Edwards Air Force Base, successful test. It's quite amazing that you can send up a UAS like this to 75,000 feet with a balloon, have it released, collect data all along its descent, return to a predetermined location with autopilot, and recover it to be able to do it again and again and again. The ultimate goal here is to do this all over the world. NOAA is working with the FAA to try and scale this or try to figure out how to characterize it. But once we get there, and I'm confident that we are going to get there, we're going to be able to routinely collect observations and data from very hard to reach locations and very hard to reach altitudes.
What's a typical day like for the NOAA Uncrewed Systems Office?
Sure. So the UAS division is a small team of about 5 or 6 folks, and again, we support all of the operations and the field work across the agency. So a typical day for us here is really just fielding the requests. So anything from, somebody decides in one of the field offices, whether they're a researcher looking at whales or seals, or they want to look at doing some air chemistry, sampling, or what have you, we'll get that request in to our office. And so our goal here is to just get that program off the ground, educate the field office and the team, figure out the platform that makes sense, figure out a way forward for training, get them up to speed, get them in tune with our policies and procedures. That's our main focus, is making sure that we get programs up and running, and we also maintain programs that are mature, and we look for ways to help these folks, whether it's applying for FAA waivers or COAs, just figuring out what makes sense for their project. So, can they do the project? Is visual line of sight? Is that a requirement they need? Do they need beyond visual line of sight? Is that something they need? What's their target of opportunity, or what is the animal they're surveying, and what makes sense? What camera, what payload, So we work hand in hand with those teams out there, because oftentimes they are the experts. They've already done the research. They know what they want. And it's a matter of approving and making sure that every T is crossed and I is dotted. And so we got to make sure that everybody's following the policy and flying safely. And
We touched upon this earlier, but can you go a little deeper into the type of opportunities you see for UAS at NOAA?
So I think the best way to answer that question is taking a step back and looking at all the different things that NOAA is doing, all the different projects across all the line offices. And so when it comes to the fisheries work that we do, or the animal population assessments that NOAA is involved with, NOAA looks at ways of collecting data and science information on hard to reach animal populations. So I'll use a couple examples. So we have a team that goes down to Antarctica every year, and they are monitoring the population of penguins. And so, believe it or not, that is a very large area of interest. And so a lot of these species are indicator species or keystone species. They tell a story in terms of how the ecosystem is doing. And so that's the challenge and the opportunity that NOAA is trying to take advantage of, or achieve, or overcome with UAS. Another example I could relay to you is whale entanglements. And so there's a lot of whale activity, a lot of whale work that NOAA is involved with. So anything from understanding the right whale population on the East Coast, right? That's a population in steep decline. So only a few hundred animals left. So it's very important that we figure out ways to track the population of those animals. Too often we see whale entanglements with fishing gear, ghost fishing gear. So with UAS, we're able to get an eye in the sky quickly versus sending out a NOAA aircraft. So we can have a UAS out there and be able to coordinate a whale disentanglement effort, right? That's a wonderful use case. There's also, this is interesting, the whale breath sampling is now something that some of our field offices are doing to characterize the stress levels of these animals and the hormone levels of these animals. They can get all that information by having a drone capture the whale breath, right? You would imagine there's a little trickiness there, making sure that the drone's properly positioned and not harassing the animal. So there's a lot of that we have to take into account as well. But ultimately, it's all about understanding and characterizing the health of these animals and how human interaction has affected their migratory patterns or just the general health, right? So a lot of work there. I'd also like to touch on the fact that harmful algal blooms are a big thing, especially down here in Florida. And so NOAA is using drones to better understand or to quickly and rapidly respond to events. Up in Alaska, lots of ice jams and flooding related to ice jams. And so we have a scientist up in Anchorage who uses drones to characterize that ice jam problem all over the state, right? So Alaska, as we all know, is a very large state, a lot of area to cover. So being able to get a UAS out to a field site or the outlying villages, it's all a matter of getting an eye in the sky quickly. So that the message can be relayed to issue, warnings or alerts. Maybe one more thing I could touch on, Randy, is the fact that, now we're trying to get drones on our NOAA ships, right? So we have a fleet of NOAA ships, and I think there's a really good use case for having, small UAS, or maybe in the future, larger UAS, for the purpose of launch and recovery on the NOAA ships. And, shoreline mapping is something that we're involved with as a mission. So UAS for that purpose is looking like a very useful tool.
What do you like most about working in this new UAS program?
What I find exciting about Uncrewed Systems is the fact that I'm surrounded by a bunch of innovative thinkers, very creative. There is that entrepreneurial spirit. The whole world of Uncrewed Systems and emerging technologies is just expanding so fast that whenever I show up to work, I'm always hearing about a new technology or a new capability and a new possible use case or a new problem that we can solve using UAS. And so it's cliche, but really no 2 days are alike. And I enjoy that. I enjoy the fact that personally, I've operated a NOAA ship. I've been a pilot for NOAA for a number of years, and now being in the Uncrewed Systems, I feel like this is sort of the trifecta for me. So I love the fact that we're able to help as well. We're able to help and facilitate our teams out there to get these assets in their hands, these UAS tools in their hands to do the work that they do so well. That's where I get my gratitude from.
Now, we've been talking about unmanned aerial systems, but there are also drones that travel on the water and below the surface. Can you talk about NOAA's use of such systems?
I'm glad you asked, because I do want to emphasize that drones in NOAA are important in every environment, right, that we're trying to study here. So when it comes to the oceans and the marine environments or lakes, rivers, streams, it's critical that we have a way to study these environments as well. So drones in the oceans, not new to NOAA. NOAA's been using Uncrewed Systems for a number of years. But I think the spotlight is shining a bright light on what's happening. And in terms of what I mentioned earlier, sail drone, essentially driving right into the eye of a hurricane. That's new. That's novel. That's never been done before. When you can send an uncrewed system or a drone into the hurricane environment, and it can withstand waves of, close to 50 feet and winds over 120 miles an hour and come out the other side intact, it's incredible, right? And so that's one example of a surface drone. And also when it comes to, let's use fisheries stock assessments as an example. So back last year during the shutdown, we weren't flying our aircraft, we weren't sending our ships out to sea. And so we were in a pinch, NOAA was in a pinch. And so we had some innovative thinkers, and again, trying to figure out how to best solve this problem. And so the sail drone was used to collect critical data on the population in the Bering Sea. At the end of the day, when the data was collected and compared to our NOAA ship acoustic data, it was spot on, right? So the ability to use Uncrewed Systems is proving to be absolutely worthy to NOAA's missions.
How can the private sector become involved in NOAA's work?
So we do a lot of work with academia and industry, with cooperative institutes in the academic sector. So, NOAA teams up with academia on a number of different projects. So that's a primary vehicle for getting a lot of, or leveraging a lot of talent. And when it comes to industry, NOAA has a small business innovative research program. If there's a need that needs to be met in NOAA and it can be met by the private sector, well, there's the SBIR program. It's almost like a competition or a request for proposals to allow industry to provide or pitch ideas that are evaluated by NOAA. That's a great way that many innovative solutions have been created, essentially, is through the SBIR process. And that process is heavily in use today. So, companies pitch their ideas, their drones, and CONOPS, or concept of operations. And if they're chosen by the agency, then they can get funding.
Looking into the future, what do you see happening at NOAA as a result of using Uncrewed Systems?
Everything is so rapidly evolving and changing even today, right? From where we were 5 or 10 years ago. Again, 8 years ago or so here in NOAA, the use of Uncrewed Systems was fairly new and novel. And now a decade later or so, that we've got a lot of great projects that we're supporting. And I think with the advent of beyond visual line of sight and those capabilities and those doors sort of opening, I think what we're going to see is a quantum leap in the ability to capture the science data that we need to really understand what's happening on our planet.
And for my final question, Paul, what message would you give to someone who's excited about science and UAS and may have a desire to work for NOAA?
The future is so bright, you have no idea. It wasn't too long ago when the Wright brothers were trying to get their airplane off the ground, and it was just for a brief few seconds or so. And here we are today. We're looking at flying taxis, potentially flying the cities around the globe. That's coming soon. That just gives you an example of how fast the world of emerging technologies is moving. And so when you bring that home to what we're talking about in today's discussion about, drones and uncrewed systems and what we're capable of with respect to science and the intersection of science and drones, right? That inflection point. There is so much opportunity there for anybody that's interested in science or technology or engineering, math, or even art, right? I would tell anybody interested in science and emerging technology to just really buckle up, right? Buckle up, because the use cases for drones are multiplying, right, by the day. And we're seeing that here in NOAA, and it's amazing to watch.
That's it for episode 339 of the Drone Radio Show. I hope you enjoyed hearing from Commander Paul Hemmick of NOAA's UAS Division. I want to thank Paul for taking the time to speak with me. If you want to learn more about NOAA's UAS Center or want to connect with Paul, check out the webpage at omao.noaa.gov. If you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1, you can help defray the cost of production. To donate, go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.